dictionaries in one little space here with no gaps in between. Do you see all these ideas stuff together really well? So let me take you into the present. Let me take you into the future. The future is something I'm working on right now with sets. Because this part is so cheap, it's only 8 bytes. Would it cost me very much to make it bigger and to double the size of it and make it less sparse? The answer is no. I hear people clapping in the other room. That's a bad sign. Okay. And so the only difference here is not this data. It is this index table. It's twice as big as it was before. It's got 16 entries, which means it went from 8 bytes to 16 bytes, and it's still smaller than Guido's name. It's the size of 2 of these hash values. It's nothing in comparison to the total table, but I've doubled the sparsity. What's cool about this is... one second. What's really nice about this structure is completely eliminated all of the collisions. If you make the table sparse enough, there's no collisions at all. And it turns out we can now make them sparse, essentially for free. We learned something new. So that's going to be in the future. Dictionaries will do even fewer steps to look up, and the same as with sets. By the way, have you seen anything that looks like this before? Really? Yes, it was up at the top of the page. Do you remember what those dinosaurs did a long time ago? In the third millennium, we reinvented databases with indexes. That said, they're pretty badass. They're compact. They iterate faster, and as a side effect of how we build them, they preserve order. So in Python 3.6, dicts are smaller and faster, space efficient, beautiful, and key sharing. And if you get 1 million instances with 1 million dictionaries, none of this data over here, these 2 columns, are repeated at all. In fact, the incremental space is just a space that is stored the values for that individual one. Who learned something new? All right. I had some odds and ends at the end. Let me just say a couple of them real quickly. We still need a hip zip hash in Python. The purpose of that is, it turns out some people are diabolical and try and create keys that intentionally collide. We fought back against them by putting a cryptographic hash that's reseeded every time Python starts up, so it's very difficult to come up with keys that collide. Also, sets use a different strategy. They use chaining and linear probing, because sets are about something different than dictionaries. Dictionaries are about looking something up. Sets are about determining whether something is actually there or not. Dictionaries, you typically know the thing is there, you just don't know what the value is. Different use cases, a different balance of strategies. A popular thing to talk about in Hacker News now is cuckoo hashing, and a number of languages are using it. How well does that mesh with this? And the answer is, nothing I've described conflicts with cuckoo hashing. Cuckoo hashing is simply a different arrangement of the index table, but the rest of this could survive. We could still do it. I don't think we should, because we have no need for densification at this point, given that we've already reached a maximum density. And cuckoo hashing is all about increasing the number of collisions, whereas making it sparse is all about decreasing it. And I think that would be a step in the wrong direction. Additionally, there's one other piece of logic inside. In a safe world, someone loops over a dictionary and they don't change it while they're looping over it. The analogy is, you put a ladder up on the side of a house, you take out a saw, and you cut out the ladder underneath you. That's what happens when you mutate a structure while you're iterating. So we have logic to guard against that, so that the dictionaries and sets won't cycle. All of this combined together is in a single piece of code. This was something that I posted about 4 years ago. It is pure Python code. It is a complete implementation of compact dictionaries from scratch, and everything I showed you is in here somewhere. The generation of the probes with Tim Peters' sequence, the dummy entries, the compact indices, the resizing logic, the fast matching, all of that is in here. And so I will post this shortly, and in the end, here's what we get. The output of this is this beautiful little dictionary, just what I posted to Python Dev back in 2012. Congratulations. Welcome to the third millennium.
Yeah.
So my name is Hui. I lead infrastructure engineering at Instagram. I'm here today with my colleague Lisa Guo to talk to you about how we've been running Instagram on the Django and Python stack. Instagram started coming to PyCon since 2012, when our first infrastructure engineer talked about building pub subsystems in Python. We're excited to be part of this community, and we're honored to have an opportunity to speak here with you all today. But first of all, you might wonder, what is Instagram? To many people, Instagram is this brunch sharing app, which is just what we should use right now on a regular Saturday morning. It started back in 2010 and has quickly grown worldwide to become one of the largest social platforms. Today, over 700 million monthly active users use Instagram on a regular basis. So a few weeks ago, Instagram was actually down because we were trying to deploy a Python optimization into production. I know. And this is what's happened on the news. But in all seriousness, Instagram is a social media platform, and our mission is to help strengthen relationships through shared experiences for people. Today, you can tell a story of your life on Instagram. You can communicate visually with your friends and family on Instagram. You can go live on Instagram. And more than just brunch photos, you can explore about anything. From animals to nature, from beauty to shopping, from F1 racing to paint mixing, which is something I learned new recently. Whatever your interest is, I guarantee you will be able to find something on Instagram. So let's go back to 2015, when I first came to PyCon in Montreal. And we had a beautiful booth and many nice tracks. And by the way, we still have a beautiful booth and nice tracks today, and you're welcome to stop by. So many people came over and asked us the same question. Instagram, what the hell are you doing at PyCon? And at first I thought, the maturity of the framework and focus ourselves on business logic and shipping product. So as an example, for over 5 years, we used the Django workflow to manage all of Instagram's user information. That is, we ran out of 32-bit user IDs way before we ran out of the capacity, the capability provided by the Django framework. And in fact, we've taken Django and Python stack quite far by now. So very early in the days, we've added sharding support to the ORM layer of Django in order to scale out the storage needs for our social graph data. Counterintuitively, we have disabled garbage collection in Python to improve memory utilization in our memory utilization efficiency. And you can follow the details of this on our Instagram engineering blog. We've also expanded Instagram to run across multiple geographically distributed data centers. And we're comfortable to scale Instagram to as many users that are interested in using it as we could find. And this is our very own Karl Meyer talking about scaling Django at the annual Django Under the Hood conference. But it's more than that. In fact, picking Python as the programming language helps to influence and shape the engineering culture here at Instagram. We prefer to use proven technologies. Our co-founder, Mike Krieger, famously said once that our users do not care what database Instagram runs on. They certainly don't care what language Instagram is developed in. The simple and pragmatic nature of Python allows our engineers, our developers, to focus on scoping and solving the real problems for our users and our products, rather than getting stuck on some language details. But you might wonder, Python is still slow, right? Well, if you were here yesterday, you know that Python is not slow for processing hundreds of petabytes of astronomy data. It might be slow if you're doing high-frequency trading or low-level bit operations. But we believe at Instagram, our bigger bottleneck is developer velocity, not so much on pure code velocity. So our conclusion, for which we're certain buyers, is that you can get to a few hundred million users with your product using Python before worrying about the performance of your framework and language. Now, that's not to say we don't care about scaling Python. At some point, we realized that as we continue to scale our team and our product, our server growth is far outpacing our user growth. And things will only get worse as we continue to add more engineers to the team and ship more product to production. So here's our strategy to address Python efficiency. We started by building extensive tools to profile and understand our performance bottleneck. We proactively push critical but stable components into native language implementations, such as C and C++. A prime example being the Memcache access library. We've also exploited using Pythonization as a weapon to dramatically improve our performance. One of our engineers, Alex Olaf, will be talking about this later in the afternoon. And finally, as we start to look for the next 700 million users, we're going to entertain some of the bigger ideas. Maybe making the whole Django stack completely async, or perhaps writing a new Python runtime. So we realize that we have a lot of challenges and opportunities ahead of us, and we're committed to continue to push the boundaries of running Python at Instagram. But there's one small problem. For a very long time, like everyone else, we run on Python 2.7 and Django 1.3. Yes, and we have even our recruiter back in 2015 knows how to say that to potential people. And we have a list of small but dirty patches sprinkled across our code base. So we thought to ourselves, we're going to be stuck on this setup forever. As if we didn't have enough challenges, after rounds of investigations and discussions, we actually decided to upgrade our entire code base to Python 3. Which, to some people, is a whole new programming language. And after a little bit of work, today I'm happy to announce that Instagram has been running its entire Django web service fleet and the salary worker fleet on Python 3.6 for a few months now. So what happened, and how did we get here? With that, I'm going